Assalamualaikum to Dr. Masuki and my friends. Okay, this video is to present to you about the sustainable product for ECS246, which is civil engineering materials. We are from group 4 of EC1104B. The group member is me, Arif, ZAKAFRI, Muhammad NAZREIL bin NORDIN, PUTRI NURSYUHANA binti HASSAN, and HUSNIYAH binti HASNAN. Firstly, the introduction of the research works that we have found, which is for Article 1, is glass powder as partial replacement of cement. For the objectives is to investigate the use of recycled crushed and expand glass as lightweight aggregate for concrete and their relationship to the material's characteristics and properties using several approaches. Next, for article number 2 is crushed glass as coarse aggregate. The objective of this research is to examine the potential of waste glass powder to produce sustainable concrete.
So for the method of waste glass powder, the first step is, firstly, stone chips and sand were dry mixed for a minute. Next, the appropriate quantity of glass powder was blended with cement in a separate container and then incorporate into the aggregate mix, which is the mix earlier. And then measure water was added to the matrix and thoroughly mixed for 5 minutes. After mixing, workability of the concrete was determined by the slump test. And next, the concrete was placed, compact and surface finished with a smooth steel trowel in cube mold. And then the material was kept within the mold for 24 hours in moist condition before demolding. Next, after demolding, the concrete was placed under fresh curing water in tank for 24 hours before testing. After 24 hours, we take out the cube sample from the curing tank, and then the sample cube concrete was testing on a universal testing machine. So this is the result and findings for the compressive strength test on a concrete. Compressive strength test of recycled glass concrete, which is 0 until 25% glass addition at different ages are shown in the figure of the result. At the age of 90 days, recycled glass concrete with 10, 15 and 20% glass addition provided mean compressive strength exceeding the control concrete, and 10% cement replacement gave the higher value among them. 25% glass addition gave slightly lower, which is approximately 2% compressive strength than the control concrete. The differences in compressive strength between the control and 25% glass replaced concrete at 180 and 365 days were further reduced and provided similar mean compressive strengths. At the 180 and 365 days, the 20% glass added concrete gave 10% and 14% higher strengths respectively than the control concrete. So the results show the compressive strength gain in glass added concrete occur at a lower rate than that in control concrete. But in a long term, recycled glass concrete has the potential to exceed the control concrete.
Okay, next we jump into the discussion of the waste glass powder. Firstly, the objective can be approved when the compressive strength test result indicated the recycled glass concrete gave better strength compared to the control sample, which is 35 megapascal at 28 days, was achieved for all samples up to 0 to 20% of the glass addition. Okay, so there's some weakness that we find, which is to conducting this research, since glass waste will interfere the alkali silica reaction, which create the higher risk to the life of the concrete when the alkaline properties are higher. The problem can be solved when the several studies have been conducted on the performance of glass in mortar and concrete to investigate the potential of the discard glass powder to produce concrete. Okay, so there's knowledge gaps that were unsolved, which is the glass addition were not conclusive considering workability and strength, which are 25% addition glass. So it can be improved with further research on durability and ASR aspect of the glass replaced concrete is required to suggest this material sustainable concrete practice. In general, considering the similar performance with a replaced material, glass addition can reduce cost of the cement production up to 14%. In addition, production of the every 6 ton glass powder concrete result in the reduction of the each ton CO2 emission from the cement production and save the environment significantly by reducing greenhouse gas and particulate production.
For the methodology of waste glass aggregates on the material properties for Article 2, which is the procedure for the test. Firstly, acute concrete samples were cut into 1 cm thick slice with a size of 50 cm times 50 cm in the middle of the specimen with a diamond blade saw. Next, the samples were polished with grid size ranging from 600 to 1500 and examined under a microscope to ensure the sharpness of the air void edge. Next, the sample surface will paint a black marker with a broad nib to cover the prepared surface. And then, the sample were then heated to 55 degrees Celsius and a white zinc paste was applied to the specimen's surface. Next, the specimen are cooled and then the residual powder on the specimen surface was removed. Finally, 2 specimens were tested for each case and each sample was tested twice. For Article 2, we obtain 4 graphs for the result and findings. Firstly, we obtain the pore structures of the specimens used to classify aggregates and pores from original image using SEM, which is Scan Electron Microscopic Micrograph of expanded glass fraction. It is to clarify the effect of different aggregates on concrete properties as well as their pore characteristic with the binder, assumed to be single phase for simplicity. For the graph, the pore size distribution of the specimen measured from new city and rapid air, which is for graph A is an NS specimen, for graph B it is for CG specimen, and graph C is EG specimen. The result indicate the aggregate characteristics such as shape, pore size, porosity, and material properties strongly affect concrete materials. And materials with advanced mechanical property as well as insulation can be achieved by using crushed waste glass as lightweight aggregate in construction concrete.
Bismillahirrahmanirrahim. For the discussion of waste glass aggregate on the material properties, the objective of investigate the use of recycled crushed and expanded glass as a lightweight aggregate for concrete. Use several tests will succeed. This is because all tests carry out and produce accurate and also a reliable result. We also find some weakness. For example, the expanded glass specimen has a low density, porous component, and this strongly affect the insulation performance of the material. The durability of waste glass also much lower than the natural aggregate when the size of glass particle is larger than 4.75 mm because of particle fracture. But according to Oliveira, the replacement all the natural sand with 4.76 mm of particle size glass will lead to a 29% increase in strength over reference concrete. And according to Du, Tan, Taha, and also Naunu, the replacing all the natural sand with 4.75 mm and 5 mm of particle glass size has no impact on the concrete compressive strength after the 28 days of cooling, but it tends to rise after 90 days.
Okay, next we move to the recommendation. For glass powder, we recommend that the waste glass powder material could be innovated as a substitute for some cement in order to significantly reduce cement production costs while saving the environment. Furthermore, tests on the durability of glass, which has replaced the use of the cement, will be expanded over the time. Okay, next for crushed glass, the replacement of sand with a waste material such as glass, sand's limited usage may be significantly reduced, as well as the annual amount of the building waste. Crushed glass also makes considerable improved material characteristic to make sure that we can provide more long-lasting building outcome while also reducing energy use and preserving the environment.
Lastly, for the conclusion, to conclude, we suggest to spread this knowledge to expand this research by using another recycled material to replace the dwindling material. We obtain the main objective of both of the test conduct throughout both article. The use of crushed waste glass aggregate can reduce the concrete density and thermal conductivity significantly, with the benefit effect of enhancing compressive and also the flexural strength. The results show that compressive strength gain in glass added concrete occur at a lower rate than the uncontrolled concrete. But in long term, recycled glass concrete has the potential to exceed controlled concrete strength. And this is the website link for the article. So that's all from us. Thank you.